Short. Yeah. Okay. Macam tak holiday. Jam quit. Why? Too short macam tak holiday. Because you play around with your cat. Kerja saja. Pejam mata dah Ahad. Wah. Assignment banyak. Okay. Anyway, this subject we don't have assignment, right? Okay. Later on we will have during close week test 2 we will have an assignment there. Okay. All right. For today class, I think will be a short class, right? So we will learn a new topic for today. The lectures 5. In this topic, I think every semester is quite to score lah this topic because there is a step and then there is a simple step. All right. Other section they will use a different method, but my section I will show you a very simple step. Okay. That is our Dr. Join, Dr. Alif, right? Why our doctor decide to open the state that can that's mean boleh rentas negeri ni, right? Yesterday I'm trying to go to JPO, right? But a lot of people there, wow. And saya tak berani lah, saya balik lah. Bahayalah zaman-zaman COVID ni. Right? Okay. So, can we start the class now?
Can, sir.
Right. Good, Arsenal. Good. Okay. Let me share my screen. How to share my screen? I forgot already. Present now your entire screen. Yeah, LCT, you are there. All right. Okay, you can see my screen, right? Okay. Keep blinking. Why is it? Why is blinking? Now is it okay?
Yes, sir.
Okay.
All right.
Okay, good. Right. Okay. Last week ago, right, or last month ago. Okay, so we have learned about how we can interpret the root locus, right, on that time, and that topic I think I'm quite I'm quite fast teach you on that, but never mind, we will repeat on that topic again for in chapter 6, I think. Okay, because we use the same concept. All right, for today we will learn about a new method, right? So there is 2 methods right now. So first is to draw the root locus, so you can determine the stability of the system and also the K value, right? That's mean your controller value, and also you can see the roots, right? So whether it can so whether it is stable or not, right? It depending on your system. Okay, right. And there is another method, we call it frequency analysis. So why we go to this method is because the time response is usually more difficult to determine analytically, especially for higher order system. So if we have a 3rd order, 4th order, or 5th order, so it is quite difficult lah if we want to draw in terms of time response, right? So that's why we use the frequency response method. Okay, alright. Blah blah blah. Okay, from the transfer function and relative stability of system can be determined from the frequency response analysis. So from frequency response analysis, we also can determine our stability of the system. And we also can see that the steady state error and so on lah. Alright. So the concept of frequency analysis, right? when you have some input here, and then of course you have some output, and then this is your gain or your controller, right? Okay. And then the difference between the output and input is only the amplitude and the phase angle. Okay. All right. So let's look this one. If you have the input, this is the for example, the input is sine, all right? Sine wave. So you will have the frequency there, and then you will see that the output will be same frequency, but you will have phase shift, right? So this is why we call it phase shift. Okay. So let me repeat this again. Now this is a simple block diagram. If you have the maybe we put it in time domain. Okay, this one YT. So what do you have this here? You have the A sine omega t. So omega, that means is frequency. So what you will get it after for the output, you will got it the different amplitude. So this is the amplitude A, and this is the amplitude B, and then you will got it as same wave lah, same signal, sine and sine, and then you will got it same frequency, but it will added the phase shift, right? So this is the concept, the different frequency analysis, all right, between this one. Okay, this is input. So this is your G. Okay, all right. Okay. If you try to plot it around from the frequency or 0 to infinity, here we got it. That's kind of graph. So what we try to plot is from 0 to infinity. Okay, so we will plot it. So we will see that only the difference between is the amplitude and also the phase shift. Okay. Okay, so let's look example 5.1. Okay, this example we give you some introduction, right? So where you can use this concept later. Okay, so I will try to derive this again, right? You have the input here, ES. Okay, now you have the YS here. So this is your controller or gain, you call it. Now you got it, time response for input is 4 sine to t, right? So what will be the difference between this? If we got it is yt equal to b, we don't know. Okay, try to b, then you got it sine, and then you got it omega is a 2t and plus p, phase angle. So I use the word phase angle. So this one the amplitude, and then this one the phase angle. Right? So we want to try to find the steady state response for output, right? This one. Okay. All right. So how to do that? Okay. This one. So what can you get it here is ut equal to a sine omega t here. Then what you got it, a equal to 4 and omega equal to 2. Right? Okay. So let's say this one is your G. Okay. So you got it GS equal to 1 over S plus 1. Alright. For the frequency analysis, we plot it between the imaginary, we call it J alpha, J omega. Alright. Right? Imaginary, that means this axis will act as your frequency. Okay. So this one will maintain area. Okay. So now when we put it G equal to JW, and now we got it JW plus 1. Right? Okay. And then you got it is J2 because your W equal to 2. Now, J2 plus 1. Okay, so to settle out this one, right, the denominator you can multiply with J2 minus 1 and J2 minus 1. Okay, alright. And then after you multiply it here, J2 times J2, you will got it 4J squared, right? 4J squared and so on. After that, you try to simplify it, right? So you got it 1 over 5 minus 2 over 5J. Okay, so this one over J2. Right. Okay, so in order to find the B here, is actually the gain here, right? The gain for you multiply with some gain here, right? In order to get the B. Okay, so we look into that. Right. Now we can find the gain, or we call it the magnitude of GJ2. Okay, so GJ2 is this one. The magnitude, I think you already know about it. Okay, this one, square root 1 over 5 square plus with minus 2 over 5 square. Alright, and then you will got it 1 over square root 5. Okay, so this is the magnitude. Okay. Then we can get it back our B here. We want to get the B equal to A with time with the gain. Now you got it. A is 4, you time with your gain is 1 over square root 5. And then you got it square root 5. Alright. Okay. So far okay boleh ikut lah. This one I think it doesn't matter lah, because this one is only to show you the what we call it, the derivation about this one. Okay, boleh boleh faham ke? Simple lah. Do you have any question? Nope.
No question.
Okay, good. So I can proceed. So because we want to find the amplitude B here and also the phase shift here. So how to find the phase shift? So phase shift is what we call it, the angle for GJ2 here. So GJ2 here is this one. Alright. So what can we have here is minus inverse tangent 2 5 over 1 over 5. Okay, and this one we equal to minus 1.107 in radian, or we can put it 63.4. Okay, why I put minus here? If you look at if you try to plot it, right? Okay, this is your JW. This is your real. Now you can see that the point for this one, 1 over 5 is here. Okay, and then minus 2 over 5 is here. Now when we plot it, right, we can get it is 1 point here, and then we try to find the angle, which just means this one. This is your P, right? This is your phase angle, right? And then of course your phase angle right now is term of negative lah, right? Because it's going to this direction, right? Negative. So now what can you have is this length is 2 over 5 and this length is 1 over 5. So that's why you got it is P equal to minus tangent, inverse tangent 2 over 5 divided with 1 over 5. That's why you got it minus 1.107 in term of radian, or you can get it is minus 63.40. Okay. Alright. Okay. This one clear? Is it clear? Oh, clear. 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 Okay. No? Do you have any question? Right? No, right? Okay. This is okay, simple. Right. So we have find the yt here is equal, b is equal to 4 over square root 5, and then sine 2t and minus with 1.107. Okay, so this is our steady state response for output, right? When you have this input signal equal to the sorry guys. Alright. Okay. Alright, so I have shown you how to derive, but I think it's a very difficult, right? You need to multiply and so on. Okay, so I will show you a simple method, right? Simple method. How to do that? Okay. Alright. Now, of course, we start from G. JW is equal to 1 over J2 plus 1. Okay, this one. So in order to find the magnitude, J2 here, what you can do is, if you see the 1 here, 1 over, it is like 1 squared, okay, the magnitude is 1, divided with 2 squared here, J, so 1 squared here, and square root. Is it? Then you will got it 1 over square root 5. Right? It's the same thing with this one, right? The same thing with this one. Nampak tak? Senang tak? Senang? Okay. Clear? Senang tak? Wow. So that means you don't need to multiply with this one because you want to cancel out this one. No need. Right? So you just need magnitude this one. Yeah, invalid. That's why you do it, right? Yeah. You just need this one, okay? All right, simple. All right, how to find the phase angle, right? Or P, okay? Only in the top. Yep, correct. Only for the top one, okay? Only for the 1 over something, okay? Right. Okay, for the P, how to find the P is very simple. You can see that 1 over, right? So you will write is minus, because 1 over minus, and tangent, inverse tangent, and then you just look at the denominator only, right? So that's mean J is 2, okay, J is 2, divide with real is 1. Yeah, that's it, minus tangent, inverse tangent 2. Right? So now you got it here is minus 1.107. Yeah. It's the same thing with this one. 2 over 5, if 1 over 5, when you cancel out this one, you will got it is 2. Right? 2 over 5 times 5 over 1. Cancel out. So you will got it is 2. Right? So it become minus inverse tangent 2. Alright. So this is the simple method. You just need step 1, and also step 2. Okay, simple. Doctor can repeat. Okay, step 2. Yeah. Alright. Okay. All is start from the J2, right? J2 here is 1 over J2 plus 1. Okay. For the P, when you see 1 over, that means it will have minus inverse tangent, and you just look at the denominator, 2j and plus 1. So that means your j is 2 divided with real is 1. That's it. Then you got it minus inverse tangent 2, where is equal to minus 1.07. Okay. So if you do like this one, the before, right? So it's 2 over 5 divided with 1 over 5. You got it, 2 over 5 times 5 over 1. You got it, is 2, right? So it is like minus inverse tangent 2, right? So it's the same thing with this one. Okay. Yeah? You want me to repeat again? Yeah. Okay, good. So then in what situation the angle will be? Okay, I need to read that. Will be positive. Yeah, we will look into that after this. Okay, then quite good. Alright. Okay. So let's me. This one, right? I'll try to solve again. So you got a B. That's mean A you time with the gain, right? So that's mean A is 4 times with 1 over 5 is equal to 5 over 4 over 5. Okay, done. And then for YT is equal to B is 4 divided with square root 5 and sine to T minus with 1.07. Yeah, done. Then you can get it full mark here. Okay, all right. So next is we will look the question from the GenQuet, right? When it will be positive. Yeah, we will look into that. Okay, done. I think I need to expand more. Yeah, sometimes others lecturer they like to use the what we call it the iPad and so on, right? In order to write the equation. But I like this one, traditional one. Okay. Done 5.1. All right. Before we okay, let's introduce for Nyquist diagram. All right. We have know about the root locus, right? The root locus. So now we know about Nyquist diagram after this. Okay, Nyquist diagram is the polar plot of the magnitude and the phase angle of the open loop transfer function. Okay, this is the keyword, the open loop transfer function. Okay, remember, open loops only, right? It's not a character equation. Character equation, you have 1 plus kgh, right, equal to 0. So for the open loop is kgh, right? For omega varies from 0 to infinity. All right, example 5.2, draw the polar plot, or we call it Nyquist diagram, right? Polar plot or Nyquist diagram is the same meaning. Of the frequency response for the integrator transfer function. Okay, just ignore the word and integrator first. Okay, so you got it, gs over gs equal to s. Okay, right. So now this is your gain is equal to s. So now we replace S equal to J or omega. Then you got it, this J omega is equal to J omega here. Okay. First step, you want to find out the gain, right? So J omega here, right? So how to find the gain? The gain is only omega squared plus real 0, right? Because you don't have real, right? You have only the J. Then you got it is omega. Right, done. This is the gain. And also the phase shift is equal. Yep. This is what have been asked by our friend James Kwan, right? If you don't have 1 over, so it will be inverse tangent, positive inverse tangent. Okay, right? So what is mean positive inverse tangent is mean take it the J first, that's mean omega you divided with 0, right? We don't have real. Then it become inverse tangent is infinity, right? Okay. Now when you got it inverse tangent infinity, I'm sure you will got it is 90 degree. Okay. How can we get a 90 degree here? Okay. Let's plot the graph. Okay, this is your real. This is your we call it, I want to call it, okay, frequency, right? This is our frequency, and here for the root local we only have the J imaginary J in real only. Okay, now so let's look how can we get it 90 degree, right? 90 degree here. Okay, so okay, let's do this one, right? So whatever the value of the omega, right? For example, omega equal to 0, the point will be at here. Okay, omega equal to 0. For example, omega equal to 1. So 1j, that's mean here. Okay, omega equal to 1. For example, omega equal to 10. Okay, this one equal to 10. For example, omega equal to infinity. So this one, infinity, right? So you will see that this is your Nyquist diagram, right? You will go to this one, and you will see that the angle is always 90 degree. Okay, right. That's why we got it always 90 degree here. Okay, clear? Clear? All right. Or we can plot it by having a table here. So step number 3, what can you have is a table here. Guys, is it too fast or too furious? Boleh Boleh ikut Okay. Okay. Now, we want to plot omega from 0 to infinity, right? We want to see what is our roots, right? Okay. So for omega equal to 0 infinity, of course, we want to plot the gain, right? Okay. And also the phase shift. Okay. For the omega equal to 0, what is the gain will equal to? Of course, will equal to 0. And but the phase shift will maintain for 690 degree. 90 degree. For the omega equal to 1, so you can see that the this one equal to 1, and the phase shift also maintain 0. For omega equal to 10, so this one is 10. So you need to correct this one. Then okay. Now you got it is 90 degree also. And for an omega equal to infinity, so you got it is infinity. Then this one we also got it 90 degree also. Okay, so when you plot it, you got this kind of point. Okay, straight away. So this is how you draw your Nyquist diagram. Okay, alright. Okay, example 5.3. Okay, do you have any question? No? Alright. Okay, so let's me continue this one. Example 5.3. Alright. So now you got it is GS equal to 1 over S. The first step is you replace S equal to JW here. Then you got it JW 1 over JW here. Okay. Then the first step, need to find the gain. W here. So is equal to, remember, 1 squared square root over with, because this is 1 over, right? Over with omega squared plus 0 squared. Then we got it is 1 over omega, right? Cancel out 1 over omega. And then number 2, in order to find the phase shift, so look at this one, 1 over, that means it will have minus inverse tangent J first, all right, that means omega, right? So your real you don't have, only 0. Okay, so we just take it is we just look at the denominator. Right? Now what you got it is here is inverse tangent and infinity, right? Because it divided to 0. Now you will always got it is 90 degree. Okay. Right? So when we want to plot it, right? We want to plot it, so we can draw omega 0, 1, 10, infinity, and so on. And then we will see that our Nyquist diagram, if we go through like this one, from the 0, right? Gain equal to infinity. If we go until omega equal to infinity, it will stop at 0 here. Okay. So maybe I can draw it a little bit. Okay, so it will start omega equal to 0, right? And then this one is omega equal to 1, and then this one is omega equal to 10, and this one omega equal to infinity. So your Nyquist diagram, you will start from here and then it will end at here. Okay. Okay. Do you have any question about it? Ada apa-apa soalan? One? Because I'm going to show you a very interesting one. Okay? No? Ada apa soalan tak? Tak ada? Boleh Is it okay? You sengap saja ni. Sengap gelita. Hello? Ada orang tak?
Tak ada doktor, tak ada.
Tak ada.
Okey doktor. Okey doktor.
Okey. Kenapa sengap saja ni? Dah tidur ke apa? Belum?
Holiday lagi sir.
Holiday lagi? Okay. Right. Okay. Example 5.4. I will go very quick about it. Okay. So you have GS is 1 over 1 plus TS. Okay. This is like your first order function, right? Time response, right? This one. So we call it a simple lagging, right? What you can do is you just replace with s equal to jw, and then this one you got it 1 over I just write it j omega t. Okay, the same. First step, find the gain. Now, find the gain is 1 squared square root over with 1 squared plus omega squared t squared. Right, okay, I just write it this one lah. Okay, and we got it this one. Then when we try to simplify it, so we can get it is here 1 plus omega squared plus t squared here. Okay, and then the phase shift, you just you can look 1 over, that's mean inverse tangent minus inverse tangent. So you just look at the denominator only. J first, omega t is over 1. Now is equal to inverse tangent omega t. Okay, so we want to plot the Nyquist diagram. So omega starting from 0 until infinity. So JGW, okay, for omega equal to 0. So 0 times 0, 0 here, that's mean 1 over square root 1. That's mean 1. Okay, 1. Right? Okay. For the phase angle, for P, omega equal to 0, 0. So inverse tangent minus inverse tangent 0. That mean is 0 degree. Alright. Then to make this simple, we can put it 1 over t here. So for the 1 over t, for the gain, the 1 over t, 1 cancel, that means 1 over square root 1 plus 1 here is equal to 1 over square root 2. So 1 over square root 2 here. 1 over t for the phase angle, cancel out, sum cancel out. That means you will got it is 1, and is equal to minus 45 degree. So minus 45 degree. For the infinity, so this is infinity, 1 over infinity, of course you got it as 0. Okay. And then for the infinity here, we got it 90 degree here. Okay. Alright, so how to plot this one? Now you got it is j omega, and this one here. Okay, for the first point, omega equal to 0, j, the gain is equal to 1. Okay, 1 here. Okay, right, you got it here. Okay. And then for the omega equal to infinity, this one is omega equal to 0. So this one is omega equal to infinity. The gain is 0. Okay. And then you will see that the graph will be something like this one. For the 45 degree minus 45 degree. So this one is omega equal to 1 over t. Right? So you will see that this kind of graph. Okay. Yeah. Yeah. Okay. So far, do you have any question about it? No? I'm going to go to interesting part. Okay. I think you will be like it. Okay. Any question? No? Okay. All right. Okay. Example 5.5. I think you can go through by yourself. Okay. So this is a simple thing lah. You got this kind of graph. For the second order, it's okay. You just can go through only. Alright. It doesn't matter this one. Okay. Right now we want to apply the concept on what we have learned so far. Okay. This will be a very interesting one. There is a method, right? will be very simple. You can use your calculator to calculate it, right? You don't need to derive all the equation here. Okay, all right. Let's say you have a series of a gain G1, G2, and G3. So how to find the output over input? You just multiply gain 1, gain 2, and gain 3, right? And then you can find the magnitude for each gain lah. And then for the phase angle or P, you just plus, okay, phase angle for G1 plus phase angle for G2 and plus phase angle for G3, okay. And bear in mind, if you have the numerator or 0, so you need to minus the phase angle. If you have the numerator, you just plus, okay. All right, this is the way how to do that. You need to derive a lot of table. Okay, this is what other section teach about it, right? But my class, I don't want to use this method. I will show you how to do that. Okay, in order to obtain the Nyquist diagram, right? So we need to plot, right, for the different frequency for omega starting from 0 and infinity. So between this one, what is the value that you can choose? What is the value that you can choose, right? Is it you can choose 1 or 10 and so on? Yep. There is one guideline where you can use it is omega means is equal to 1 over time constant max. Okay, I will show this one. And omega max is equal to 1 over T min. Okay, so this one will shows that what is the value that you can choose for the frequency, and this one omega max. Okay, right, good. So this is very interesting part. Let's go example 5.1. Guys, are you okay? Boleh okay, so please look this one carefully. Okay, boleh ada apa-apa soalan? Tak ada? Ada apa-apa soalan?
Tak ada, sir.
Tak ada. Okay, good. Alright. Fidaus, if you want to record, yeah, you can. Alright, 5.1. Let's say you have this kind of block diagram here. 4s plus 2. Then tak boleh pakai handphone. Okay. Tak apa. Duduk kat luar tengah dating Okay. Right. So this is like your G1 and G2, right? And then you need to make a sum table and so on, right? That one is very, very difficult one because you will do a mistake about it. So how to solve it is simple one. First, you need to find the open loop transfer function, where I mean the KGH, right? You don't have the KGH, you don't have K, right? So it means that G1 times G2, right? So you got it 4s plus 2 multiply with 2s plus 4 here. Then you got it is 8s plus 2s plus 4. Okay, right. And try to simplify this one first to be like 1 plus time constant s, okay, to be like this. So what can you have it? 8, 2 times 1 plus 1 over 2s times 4 times 1 plus 1 over 4s. Okay, so you can look this one. I try to make it same with this one, 1 plus ts time constant s. Okay, right. So when we simplify it, we can get it 1 over 1 plus 0.5s, 1 plus 0.25s. Okay, now this is, I put it is gs lah. Okay, to make it simple. So that means you can relate on what you have learned before this. Okay, right. So this one 1 plus ts, right? So this one 1 plus ts. All right. So remember, the last one I showed that omega means equal to 1 over T max. Right. So you can see that where is the T max? The last value, right? 0.5. So 1 over 0.5 equal to this one equal to 0.5 equal to 2 radian per second. This will be your guideline. And then omega max equal to 1 over T means 1 over 0.25. This one equal to 4 radian per second. Right? Okay. Why we draw this one? Because later on we want to plot it, yeah, from 0 until infinity. Okay, we want to plot it again, GJW, the gain magnitude, and also the phase angle. What is the between this one? So between is 2, right? Number 2, and also number 4. Okay, so you can see the application, right? This is the guideline, 2, 4. Okay, so that means your omega need to have 2, need to have 4. Right? So that when you plot it, the Naive diagram, it will be very smooth. Okay. Done. Next part, you have any question? No? No? Okay. This will be an interesting part. All right. Now you got it. GS is equal to 1 over 1 plus 0.5s, 1 plus 0.25s. Okay. Then we put is G equal to JW 1 over 1 plus 0.5. Put it is J 0.5W. Alright, 1 plus J 0.25W. Okay. Our objective, we want to find this one, and I want to find this one. Okay. Right. Because we want to get all the value for this one. Okay. Alright. Okay. Before this, I teach you, okay, for JW, so we can find the 1 squared, right, over over what? 1 squared plus 0.5 omega squared, right? And time with the 1 squared plus 0.5 omega squared at 0.25 omega squared, right? And then you can find here is 1 over square root 1 plus 0. Omega squared 1 plus 0.25 omega squared, right? Okay, so then you need to use your calculator. You apply this one, omega equal to 0, this one, omega equal to 0, and then you can find this value, right? Betul? Right? Betul Alright. Hello guys. Boleh?
Boleh sir, boleh.
Okay, now I'm going to show you a simple method. Okay, so you can go through my slide here, you can go through my solution here, but that is a simple method. Are you going to know about it? Are you going to look about it? Are you going to hear about it? Okay, right. Nampak tak? Boleh? Dah ready. Macam mana simple method nak guna? Okay. Right. Now, take out your calculator here. Okay. Boleh? Dah bawa keluar dah calculator?
Dah.
Dah sir.
Dah, okay. Now, our part is we only want to get this table, right? We want to fulfill all this value, right? So, and then I just show you how to find the JW and so on, right? But for this part, you don't need this one. Okay, now start to use your calculator here. Okay, so try to what we call it, construct this equation. First of all, you need to choose your mode, right? To choose your mode to complex, right? To complex, number 2. And I think another thing that you need to choose is okay. Yeah. Another thing I think you need to choose, if you use the calculator, you just press shift and you just press setup right here. Okay. And then you just go to this one, right? Press your arrow button, right? And then you can see the complex, right? Number 3, you just press 3. So it is want you to choose between this one that have the J and also the real, or you have the magnitude and also the phase angle. So right now choose number 2. Okay, done. Okay, boleh ikut tak? Boleh?
Boleh.
Okay, good ah. Too simple thing.
Boleh.
Okay, so now we just create this equation, right? This equation. So 1, I try to write it first. 1 over parenthesis 1 plus 0.5 AI time with 1 plus 0.25 AI. Okay. Now, yeah, we just write the equation 1 over 1 plus 0.25 AI, or the first thing, yep, 1 over 1 plus 0.5 AI. A, that's meaning that's been unknown, right? I think you know already how to write the unknown, right? Boleh kan? Macam mana nak tulis A tu tahu kan?
Tahu sir.
Tahu saya tahu.
Okay. Then you just can press the solve here, right? How to show that? Okay. You just can press the solve here, right? The calculate here, right? Calculate. Okay, it asks you what is the value of A. Then you can put our first one is 0, omega equals 0. A is that mean your omega. You put it 0, and then you press equal. You press equal, right? Yep. Wait, I try it again. Okay. 1. Yeah. That's mean when you put it 0, that's mean the magnitude is 1, okay, and then the angle now is 0, okay, 1, and the angle now 0, okay. Right now you don't see any angle, right? So maybe we can put it, calculate 0.0001, for example. When we press it, enter, you will see that the magnitude is 1, and then the angle is minus. That's mean 0 lah. Okay, 0. Okay, 0. Okay, we can start with 0. So we can get it the phase value. Okay. Okay, boleh tak? Boleh ikut tak? Faham tak konsepnya? Right. And then try to omega equal to 2. So when you put it, calculate A equal to 2, right? So this is 2, right? Okay. Now you put it equal. So you got it is the value is 0.62. 0.632, and then your phase shift is minus 7.71.6 degree. Okay, boleh? Simple kan? Simple, right? So you don't need to derive all the JW and so on, or the P and so on, right? You don't need to derive, so you just put in the value, calculate, and omega equal to 4, equal, then you record it is here, 0.316 here, okay, and the phase angle is minus. Please take also take the minus 0.18. Okay. So by using this calculator, you can get it all this value. Believe me, you can get all this value. Okay. Macam mana? Okay tak? Senang tak?
Senang sir.
Senang kan? That means you don't need to derive all this thing. You don't need to derive all this thing, right? You can find it straight away by using your calculator. Okay? Magic, right? Yep, Muhammad Al-Maudi.
I couldn't get the same answer. It just showed me one answer. The calculator, it just showed me one answer.
Sorry, I cannot get what you said.
When you press for calculator for A, I didn't know the last step in the calculator. I didn't know how you do it. Can you repeat it again?
Oh, you want me to repeat? What is it?
The last step when you press calculate for
okay.
A.
Yeah. You put it A, right? And then you put it the value is 4, right? Okay. Then you got it and then you press equal here, equal. Okay. Press equal. So you will see this value 0.316, and then the phase is minus 108.4. Okay. Right. And then of course you cannot try for infinity. So how are you going to put infinity here, right? It is very difficult. So let's say we just choose any last value, for example 4, because this 4 is the omega max, right? The frequency maximum. You can put more than 4, for example I put 10. Okay, this one I put it 10. Okay, equal. Then I got it 0.07. Okay, and then the phase angle is 146. Okay, 146.8 degree. Okay, right, done. This is 10. So you will see that the gain is almost going to 0, right? So I think it is enough for us that we can get all the data. So in order to draw smoothly, you can add another value. For example, between 0 and 2, you can put it is 1, for example. 2 until 3, you can put it 3, for example. Just use your calculator. You don't need to calculate like this one, right? You don't need to calculate like this one. Okay, simple, right? And also you don't need to derive all this value, right? Only this section that I teach you this method. Okay, but however the what we call it this disadvantage for this method, if you got it the value is wrong, the value is wrong, that means you will lose this mark on this table, right? Okay, so, but make sure you you try to check your value. You try to what we call it, double check this value. So I got this kind of method is from the students, right? So they do the part time, right, for degree. So they think, oh doctor, we can just use straight away your calculator. Oh yeah. Okay, right. And you can try another example, right? Another example, like let's say this one, right? You just type 10 over AJ multiply with 1 plus 0.25 AJ, right? Plus I will finish it a little bit, right? 1 plus 0.05 AJ. Okay, right? Amboi Ahmed Mahmud. Alright. Before this, you don't say anything, right? Now you just say, okay. Alright. Later on, the next week, we will learn how we going to plot this one. Okay. We will learn how we going to plot this one in the polar plot. Yeah, we will use this kind of polar plot. Okay. Yeah. Okay. Yeah, we will learn how we're going to use this polar plot, and I hope that you can download the polar plot, right? So I will give it to you. You can download the polar plot here, right? So this is the polar plot, right? So there are many angles here, so you can download this one. So we will do it together in the class, right? So this is the polar plot. So I will give it to you after this in the WhatsApp group. Okay, so I hope that on the next class you download this one and we will plot is right. We will plot it together, right? One by one, based on this value that we got it. Okay, is it okay? Whereas, wow, I so mind blown using calculator. Yes, Daniel, good. So there are a lot of things we can use using calculator. Okay, so I think that's it for today. Sorry, I'm dragged a little bit for class. So we see you again on this Thursday, right? Okay. Assalamualaikum. Do you have any question? No? Okay.
No question, doctor.
Okay, good. That's it.
Thank you, doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Thank you, doctor.
Thank you, Doctor.